So we begin Unit 5 by looking at total revenue. Now understand that total revenue does not mean profit. Those are two completely separate words. Profit is what you get when you take total revenue minus total cost. In this lesson though, we'll focus completely on total revenue, which is just what they make before subtracting what it costs to actually produce a good. Okay, so let's begin with looking at total revenue. So total revenue is the amount paid by buyers and received by sellers of a good. Total revenue is calculated as total revenue is equal to price times quantity. Really, really important right off the bat. Understand total revenue is not profit. Okay, profit is something completely different. Profit is total revenue minus total cost, whereas total revenue is just what they bring in. So when we mention the word total revenue, all we're talking about is the price of a good times the quantity that's bought. So when we look at this graph, we can pull a demand line and we can pull our supply line, and where those 2 points meet our market equilibrium, that is our total revenue point. So in this case, we take $4.99 times 4.4, and that gives us $21.96 for our total revenue. Now, if we were to see a shift in demand to the left, notice total revenue, of course, is going to change, and now total revenue has moved down. So price is now $3.50, whereas quantity is 3.5, and our total revenue is now $12.25. So when changes occur in the market, the total revenues will change as well. Now, one of the things we use in discussing total revenue and focusing on the amounts of total revenue is this, what we call the price elasticity of demand. So price elasticity of demand measures how much the quantity demanded of a good or service responds to a change in price. And this measure is tied to total revenue because the elasticity of demand determines what effect an increase in price or a decrease in price has on total revenue. So why does this matter? Well, let's think about this for a second. So price elasticity of a demand is going to tell us how much quantity demanded will change because of a change in price. If price changes a little bit and quantity demanded changes a lot, there's one issue. If price changes a lot and quantity demanded changes very little, that's a whole different issue. So it's important to understand that when you're a business, what changing prices is actually going to do to your total revenue. So businesses can use this concept to determine whether a change in price would increase or decrease revenues. So this term elastic. Demand is said to be elastic if the percentage change in quantity demanded exceeds the percentage change in price. So, for example, if price increases 15% and quantity demanded falls 25%, then we would say that demand is elastic. Now, demand is inelastic if the percentage change in quantity demanded is less than the percentage change in price. So if price increases 15% and quantity demanded falls 5%, then it's inelastic. So we use the two terms elastic and inelastic are used to describe whether or not a change in price has a significant or a minor outcome on quantity demanded. Okay, so on this slide, we're going to look at elastic demand and give you an example of what elastic demand looks like. So elastic demand, so if demand is elastic, then a change in price will cause a decrease in total revenue. Okay, so make sure you remember that. So if demand is elastic, then a change in price will cause a decrease in total revenue. So let's draw this line here. Now, elasticity is based on the slope of the line. So it's pretty simple. When you look at this line, notice how it looks compared to when we look at an inelastic line here in a second. The slope is the difference. And one of the easy ways for you to tell if a line is going to be elastic or inelastic is looking at the slope of it. So we take this box here. So at this point here, $4,000 times 7,000 quantity gives us $32 million in total revenue. Now, if we come over here and we increase that, we've increased our price from $4,000 to $6,000. So at $6,000, we only sell 4,300, which gives us a total revenue of 25.8 million. So notice, of course, that when demand is elastic, an increase in price will decrease total revenue. So we have here, since demand is elastic, the increase in price caused revenues to fall $6.2 million. So in this case, it would be a bad idea to raise prices. So when you operate within a market with an elastic demand, raising prices is simply not a good idea. So why use demand to calculate elasticity and not supply? Well, the answer to this one's pretty simple, really. Total revenue is generated from consumers bought. Therefore, we study demand. When we talk about total revenue, we're only talking about what is actually being sold. Well, of course, what is being sold is what consumers are purchasing. Now, total cost, on the other hand, would be studied by focusing on supply because that's the amount we make. And remember, total revenue minus total cost is going to give us profit. So now this time, we will look at inelastic demand. So on inelastic demand, if demand is inelastic, then a change in price will cause an increase in total revenue. So notice the slope of the line, it's much steeper. So when we plot our point here for this total revenue, so total revenue here equals $3,500 times 5,500 in quantity, which gives us a total revenue of $19.25 million. Now when we look at the other one though, if we increase price here, now notice what our inelastic demand says. We should see an increase in total revenue. So total revenue is equal to $5,500 times 4,000 equals 22 million. So notice if a demand is inelastic, an increase in price will reduce quantity demanded, but it will still increase total revenues. So in some situations, companies can increase prices and still increase total revenue. In other situations, companies can increase prices and actually lose money. So since demand is inelastic, the increase in price caused revenues to rise 2.75 million. So really, really important. If you are a business, you need to understand what kind of market you operate in. Are you operating within an inelastic market in which you can raise prices and raise revenue, or an elastic market in which an increase in prices will actually cost you revenue? So in this example, we see that demand is less responsive to a change in price. In our previous example, demand was more responsive to a change in price. So that's the key thing you're thinking about here. So elastic is more responsive to a change in price. Inelastic is less responsive, and therefore in inelastic markets you can increase prices and actually increase total revenue. Okay, so why are some goods more elastic than others? This is an important question to think about. When we look at our market, some goods are elastic, some goods are inelastic, and of course that matters. So what makes that difference? Well, much like with demand and supply, we have our determinants of elasticity. So these are the things that will determine how elastic something is. So the four are availability of close substitutes, necessities versus luxuries, definition of the market, and time horizon. And we'll look at each one individually. So we'll start with availability of close substitutes. So goods with close substitutes tend to have a more elastic demand because it's easier for consumers to switch from that good to others. So the more substitutes a product has, the more elastic its demand is. The less substitutes, then the less elastic it is. So think about products that are very similar, Coke and Pepsi, for example, or let's say fast foods from hamburgers. You suppose McDonald's increases the price of their hamburgers. Well, consumers can easily switch to other places for a hamburger. I mean, you got Burger King, you got Wendy's, you got Hardee's. So as a result, an increase in the price of hamburgers at McDonald's would lead to a loss in revenue because of the fact that it's an elastic good. So the more substitutes an item has, the more elastic it is. The less substitutes, the more likely it is to be inelastic. So pretty easy one on that one. So goods without close substitutes tend to have an inelastic demand since they are harder to replace. The demand for water, for example, is inelastic due to the lack of substitutes. Try and replace water with something else and see where you get. Because there's no substitutes for water, water is very inelastic. Okay, so our second determinant here is necessities versus luxuries. Necessities tend to be inelastic due to the fact that if prices rise on them, the demand for them does not change much. Necessities have few substitutes. So when goods are necessary, when we must have them, the market for them is inelastic because there's just not enough substitutes available for them. Take luxuries on the other hand though, these are elastic because of the numerous substitutes. When you talk about like watches or cell phones or iPads or computers, there's so many substitutes out there because they're considered luxury goods. Now, third factor here is definition of the market, which kind of rolls right in with that idea of necessities and luxuries. When we talk about the definition of the market, the elasticity of any market depends on the boundaries drawn for that market. So the more narrowly defined the market is, the greater the elasticity for it is. And that's due to numerous substitutes. So you can think about it like this. If the market is cereal, then it's more elastic since there's so many types of cereal out there. So because that market name is cereal, we've narrowly defined it. Now we have more substitutes available. But the broader the boundaries of the market become, the more inelastic the market becomes. So while cereal is narrowly defined and is thus an elastic market, food is a broad definition of the market and has a significantly lower elasticity since food has little substitutes. So you'll notice the huge part of what makes something elastic is the number of substitutes available for it. And when you talk about food, there just aren't substitutes for food. So therefore, when we talk about food, we're talking about an inelastic demand. But when we talk about cereal, we're talking about an elastic demand. Okay, so our fourth determinant is time horizon. So the longer the time has elapsed since a price change, the more elastic the demand. So if a price change occurred recently, then the demand is more likely to be inelastic. So if prices are changing, say, this week, then demand is likely to be inelastic. If prices changed, say, 2-3 months ago, then that same demand, which had been inelastic, will now become elastic because there's been a greater amount of time, and thus what's going to happen is we're going to see, as prices don't change, we're going to end up seeing more substitutes within the market. So how do we calculate the price elasticity of demand? And we'll walk you through this and make it very detailed so it's easier to remember. And this isn't something you'll have to do in class all that often. So let me give you the formula first. So price elasticity of demand is equal to a percentage change in quantity demanded divided by a percentage change in price. So that's our formula. So we want to break that down though. So first, we calculate the percentage change in quantity demanded. So here's how we do that. So percentage change in quantity demanded is equal to, you'll notice your QD1, or what I put in parentheses there, new, minus QDO, which is the original. So you're going to take the new demand minus the old demand and divide it by the old demand. So new minus old divided by old. So you'll take that answer and multiply times 100 and you get the percentage change. So if that answer is 0.2, then times 100, then that would give you a 20% change. Now here's what you'll need to remember. The way we did this is always with an increase in price. So this number will come out negative, but we're going to ignore the negative sign, and we're only going to focus on the percentage change, which is 20. But we know that would mean that quantity demanded fell 20%. So then we'll calculate the percentage change in price. So percentage change in price, so that's P, is equal to P1, which is new, minus PO, P0, the original, divided by P0, the original. So the formula is the same for both of them. We're just using quantity demanded on the top and price on the bottom. So the new price minus the old price divided by the old price. Take that answer, multiply times 100, and that gives you your percentage change. So divide the percentage in step 1 by the percentage in step 2. The number, we want to keep it as a decimal point here. So we're just going to manage the decimal. Now, this is what we end up with. So numbers less than 1, like say a 0.8, are inelastic. Numbers greater than 1, like 1.2, are elastic. Most of the time, numbers will be inelastic. So when you calculate this, if the number is less than 1, it's inelastic. If the number is greater than 1, then it's elastic. Okay, we're going to put this into practice here and look at price elasticity of demand. So we'll bring our graph up with our demand curve, and we'll plot a couple of points here. So on our first one, we'll have here, we have a price of $3.5, so $3.50, which creates a quantity of 5.5, and so that's our original price. Then we take our second point here, and we've got a price of $6 with a quantity demanded of 3.5, and so that's our new price and quantity demanded. So there's our original and there's our new. So the first thing we'll do is calculate percentage change in quantity demand. So we'll take 3.5 minus 5.5 and divide that by 5.5. So remember, these are our quantities down at the bottom. So when we do that, we get 0.36. So we multiply that times 100 and we get 36%. So ignore the negative. Now what the negative tells us is that quantity demanded, our quantity here, our QD, fell 36%. So the percentage change in price, we do the same thing. So we'll take the new price, which is $6, minus $3.50, divided by 350, and we get 0.71. So that's 71%. So what we're saying here is that price increased by 71%, causing quantity demanded to fall by 36%. So the price elasticity of demand, 0.36, divided by 0.71 is 0.5. So this is inelastic. And that's what we look at. Now we can calculate and also look at the total revenue to make sure. So here we see this 71% increase in price causing a 36% decrease in our quantity demanded. Now, how does that affect total revenue? Well, on the original total revenue was $19.25. By increasing the price, our total revenue increased to $21. So if you are the producer, did you make the correct decision in increasing your price? The answer is yes. The reason why the answer is yes is because the curve is inelastic. If this curve were elastic, then we'd be looking at a whole different answer. Then we know we'd see a fall in total revenue. But because in this market demand is inelastic, increasing price increased total revenue.